Hi, in this video I will explain this problem. So the problem is, so the base of the solid is bounded by y equal to x cube, y equal to 0 and x equal to 2. Okay, you can see from this is the graph of, so this is the y equal to x cube, y equal to x cube, and this one is y equal to 0 and this one is x equal to 2. Okay, so now we have to find the volume of the cross sections taken perpendicular to the x-axis form a rectangle whose height is 2 times its width. Right. Okay, so we have to find the volume of the cross section perpendicular to x-axis. So the cross section perpendicular to x-axis form a rectangle. So whose height is 2 times its width. Okay, let's take the rectangle. Okay, let's take the rectangle. So this is the rectangle. You can see the width equal to, this one is the width and the height is 2 times its width. So that is, it's the height equal to, let's say that is 2w. Right. Now, so the width equal to, so this is the width, this width is equal to this one. So the how to find the this length, so we can now subtract that of the top curve minus bottom curve. So here the base equal to, we have the base equal to the top curve, that is the y equal to x cube. Okay, so that one is x cube minus that bottom curve is y equal to 0. So that is the base equal to x cube. Right. So that is the area of this rectangle is a equal to the width times height, that is the width times height. So the width equal to w and the height equal to 2w. So that is the 2w square is the cross sectional area, but w equal to this one, the w is the base. Okay, so that is, so this is equal to w. So 2 times w is x cube. Okay, w is x cube and whole square. So that is our 2 times x to the power x cube whole square is x power 6. So this is the cross sectional area. Okay, so now we have to set up the volume integral. So the volume is v equal to, so we have to accumulate the volume. So from accumulate the areas of cross sectionals from x equal to 0 to x equal to 2, right? 2. So we have to integrate the area, cross sectional area, from integral 0 to 2 and a of x dx, that is the 2 x square x to the power 6 dx. So this is the volume integral. Okay, so to find the volume we have to evaluate this definite integral. So this is equal to, so we can factor out the 2 from the integral, that is the integral 0 to 2 x to the power 6 dx. So this is equal to 2 times the integration of x power 6 is x power 6 plus 1 over 6 plus 1, and substitute the limits at 0 to 2. Okay, so this is equal to 2 times integral x power 6, that is the x power 7 over 7 integral 0 to 2. So that is the, we can factor the 7, 2 over 7 x power 7 and the limits are 0 to 2. So that is the 2 over 7 x power 7, that is the 2 power 7 minus 0 power 7, which is 0. Right. So that is, so the volume is v equal to 2 power 7 over 2 power 7, right? That is the 2 power 8 over 7. So 2 power 8 equal to, so let's find the 2 power 8. So 2 power 8 is 256, so that is 256 over 7. So this is the volume of the solid whose cross section perpendicular to x-axis or rectangles. Okay, so this is the volume. So this is the part A. Now let's see the part B. So now let's see the part B. Find the volume if the cross sections taken perpendicular to the y-axis form a rectangle whose height is 6. So whose height is already given. So the rectangle whose height is given, that is the 6, and the width equal to where the cross sections are perpendicular to y-axis, right? So these are the cross section perpendicular to y-axis. So this is the width. Okay, so this is the base and this is the base, right? And here the base is the difference between the x values. Okay, that is the base is the difference between x equal to 2, the right curve minus the left curve, that is the x value, that is the x equal to y equal to x cube. So x equal to y power 1/3. So that is the y equal to y power 1/3, right? So this is the base. Now the area of this square is the area equal to base times the height, that is the 6. So that is the 6 times the base equal to 2 minus y power 1/3, right? So this is the area of this rectangle cross section. Okay, so this is the area of this rectangle cross section. Okay. So now to find the volume we have to set up the integral. So the volume is v equal to, so the volume is the accumulation of all the cross sections. Okay, so these are the cross sections from y equal to 0 to y equal to this point. Okay, so we have to find the intersection points of this one. So that is, so the intersection point is, so we have to find the intersection of y equal to x cube and x equal to 2. So that is when we plug x equal to 2, we have y equal to 8. Y equal to 8. So this is 2 comma 8 is the intersection point. So now we have to integrate the cross sections from y equal to 0 to y equal to 8, and the area of the cross section is 6 times 2 minus y power 1/3. Okay, with respect to dy. So here the 6, we can factor out the 6, integral 0 to 8 2 minus y power 1/3 dy. So this is the volume integral. So to find the volume we have to set up we have to evaluate this definite integral. Okay, so let's evaluate the definite integral. Okay, so we have v equal to integral 0 to 8 6 times, so integral 0 to 8 2 minus y power 1/3 dy. So that is the 6 times the integration of 2 is, that is the 2 times y, minus integration of the y power 1/3 is y power 1/3 plus 1 over 1/3 plus 1, and the limits are 0 to 8. Here 6 times, so we have the 2y minus y power 1/3 plus 1. So 1 is the 3/3, so that is the y power 4/3 over 4/3, and 0 to y. So we can now rewrite this as a 6 times 2y minus, we can now multiply this fraction by inverting the fraction, that is a 3/4 y power 4/3 integral limits 0 to 8. So that is the, so like the upper limits, that is the 2 times 8 minus 3/4, and y is 8, right? Y is 8 8 8 4/3. Okay, minus, when you plug the y equal to 0, you can see both term contains 0, we have 0. So that is 6 times 2 power 8, 2 times 8, yeah, that is the 16 minus 3/4. So here the 8 can be written as t cube and 4/3, right? So this is equal to, so 6 times 16 minus, so here the 3 get cancelled and 2 power 4 is, that is the 3/4 16, right? So this one equal to, so 16 minus 4 ones 4 fours, that is the 12. So that is the 6 times 16 minus 12, which is 4, that is the 6 4 is 24. So therefore the cross sections, the volume of the cross sections perpendicular to y axis, or the volume is 24 units.